All right. Hello, everyone. So this should be the live stream for 10600, the math background for machine learning. Hopefully, everybody's receiving the live stream okay, and can see when I switch back and forth to slides and video. So we'll go from here. All right, so there are a few things that I wanted to that I wanted to talk about. We will start with just a few things about the class in general, and then we'll get right into the class content. So let's see. I guess. So I guess we'll start with the goal for the class. So the goal for the class is basically to have you guys practice math and learn new math that you're going to need for machine learning. This is specifically for people who are interested in taking later courses in the machine learning department, like 601 or 701, which are Introduction to Machine Learning, or Graphical Models, which is 708, or 605, which is Big Data. This course is for now completely optional, but if it goes well, if people like what we're teaching, then we'll potentially require it, and maybe have hundreds or even, in my wildest dreams, thousands of students taking the course at once. We'll see what actually happens. So you can see we're doing the course online. We're doing it online for a couple of reasons. One is scalability. We don't, if we have hundreds and hundreds of students, then there actually aren't any classrooms on campus that can hold that many students, and so I have to do it online. Maybe even more interesting is that we'd like eventually to have students be able to take this course remotely. Maybe master's students take this over the summer, the first semester, or before the first semester they get here. So the other thing that we're going to do, so this is a mini course. It's in the first mini of the fall semester. We're going to offer another course in the second mini of the fall semester, which is more of the same. So it's going to be, again, math for machine learning, but possibly if you like this course and want more depth, consider signing up for the second mini course. All right, so the first thing I wanted to do was introduce our TAs. So we'll start with that. So you guys should now be able to see just the slide stream. So we have, in addition to myself, we have three great people working to help you guys understand stuff. Marcus Woodson is a master's student in ECE. He's interested in the stuff you see on the slides here. His contact info, by the way, I've got contact info for all of the PAs on Piazza. Possibly you'll get a chance to interact with the TAs during class today. We're going to have some exercises and give people a chance to start interacting with the class. So this is Marcus. The next one is, the next person is Mengchen Li. She's a Master of Science in Computer Vision. She does a bunch of interesting research in computer vision. She's in the RI. We also finally have Bryn Edmonds. So Bryn is an assistant instructor. You can think of that as like TA++. Basically, she's going to be managing our group of TAs and hopefully helping you guys understand the class material as well. Bryn has a Master of Science in Medical Physics. She's done a bunch of cool stuff with understanding, for example, medical imaging. All right, so that is our course staff. So the next thing, I guess, is Since this is an online class, and probably most of you guys don't do too many online classes in CMU, what is the class going to be like? How are we going to run the classes? So you can see already, obviously, we're doing lecture streaming. The lecture stream should hang around for a bit on my YouTube page so that you can go back and look at them. But we do ask that you do the lectures synchronously, so stream them at their actual live time of 1:30 to 3 on Mondays and Wednesdays. The reason for that is to enable interactivity. So with an online course, the thing that's really, really hard to make sure that happens, it's really hard to make sure. Oh, cool. Okay, so we're actually starting to get questions already on the YouTube stream. We'll get to those questions soon. So interaction is the key thing that's going to be difficult to manage. So there's going to be several ways that you can interact with us. One is through Piazza. So we've got the TAs watching the Piazza site, and so if you can ask questions on Piazza, the TAs can make sure to answer them. So that's probably the best way to ask the questions, because that way we can answer them in a forum where everybody can see the answers. But that's not interactive, right? So for some questions you just need interaction. You're working on one of the in-class exercises, you've got your code, for whatever reason it's not compiling and you can't figure out why. So we've posted the Gmail of all of our TAs, and of course mine as well. During class you can set up a Hangouts chat with the TAs. The best way to do that is just to send them a text message and say, are you available for a call? That way if they're on a call with another student, they can get to you as soon as they're done with the other student. And then, right, there's the YouTube chat as well. I had been thinking that Hangouts would be easier and Piazza would be easier than the YouTube chat. But I guess the TAs are texting me that they can monitor the YouTube chat as well. So you can that's a possible way of doing interaction there. Again, the YouTube chat is anybody on the planet can post YouTube chat messages, although hopefully not everybody on the planet is watching my stream right now. And YouTube chat doesn't preserve everything in as nice a format as Piazza. So I think I'm just going to, unless people have a strong preference, the other way I'm going to say Piazza's the line of first recourse, and then after that Hangouts and Google Chat for people who have trouble accessing the other two for whatever reason. All right, so let's see. So we're going to have a mix in the classes of lecturing and working on problems. So for this class, because I haven't, this class is the first class, I haven't posted lecture notes or questions for you guys to look at before. So we're going to have sort of a bit of lecture followed by some problems. In general, the way things are going to work is that I'll post ahead of time some lecture notes for you guys to look at. The goal is that it shouldn't take a long time for you to work through them. You should read them. There'll be questions in line with some of the lecture notes. The questions will be more of the understanding check variety. They won't be like long exercises that you have to complete. But they'll be due before the beginning of class on every class. And then in class, I'll go over any questions that people have posted on Piazza or that people have asked in office hours. I may lecture on additional topics, and we'll do exercises for everybody to work on jointly. Let's see. So what else do we need to know? So you guys have presumably all already joined Piazza. If you haven't, look at your Andrew email. There's a link there to join the class on Piazza. The Piazza has a whole bunch of useful posts there, including like, what are the grading criteria for the course? What does the syllabus look like? All of that sort of thing. I'm going to assume that you guys can read those offline. I'm not going to waste lecture time on them unless there are questions. In particular, I want to point out there are posts on the grading, like what percent goes with what activity, the syllabus, and there's also a post on collaboration. So I just got a text, do we plan on releasing the slides? Yes, we do plan on releasing the slides after class every day. The lecture streams will also be available to go back through, although you may want to fast forward through the parts where we're working on problems if you're going through them afterwards. All right, there's collaboration. There's a post on collaboration. Basically, we encourage collaboration between students in the sense of like forming study groups, helping each other work through all of the problems. What we do not encourage is for you to discuss the exact solution with other students. You should discuss solution strategies, like what do you need to know, what are the tools that you need to work through it. When it comes time to submit, you should submit all and only your own work. So that means to put away any notes that you have from a study group and work out the solution using a strategy that you might have discussed with other people, but work out the solution yourself. And it's important to put away your notes because if you're looking at your notes while you're doing it, the solution can go from the notes to the paper or to the electrons in the case of online submission without ever passing through your brain, right? Or without sticking in it. Whereas if you put the notes away and you work on the solution, then you have a better chance of remembering it when it comes time that you need it later. All right. And of course, please don't post solutions or code on Gmail, Piazza, any of our discussion sites, right? Just post questions about strategy, but not actual solutions. All right. So now I think it's time to get to the actual course content. So let's go back to the slides. We'll get a why are we not going to the slides? Okay. Oh, of course, we do have the slides. Now we have a blank slide, and we can use this. Oh, I got a text, a question whether students can rewind video. Yes, you can rewind and fast forward video. You can use it. Another thing that's actually pretty useful is if you happen to rewind to go back and catch something, you can start watching on double speed and catch up to real time that way. Hopefully I don't look too funny in double speed, but we'll see how that looks. All right, so let us start with the actual content. So I'm going to post lecture notes for the content after class today. For the content that I'm discussing, and then today or tomorrow I'll post some lecture notes for the content that you guys will be needing to review for Wednesday's class. So the first thing that we're looking at is sets, right? So you've probably seen sets before. They're an unordered collection of objects without duplicates. A set is completely determined by its elements, so two sets are equal if and only if they contain the same elements. One set is a subset of another if all of the elements of the one are also elements of the other. So you can have finite sets like the primary colors, red, green, and blue. You can have infinite sets like the integers or the real numbers. And this probably is review for all of you. The thing which may not be review, or which might be good to get practice with, is what's called set builder notation. So we use that a lot. Set builder notation is basically a way for us to describe complicated sets using logical properties. So a typical example would be something like the even numbers. Oops. Right. So the even numbers. Looks like this, right? It is the set of everything you can write in the form 2x, where x is an integer, right? So I'm using z for the set of integers. That's pretty common. And then the even numbers are the ones that are twice an integer, right? And so in general, this is of the form we have an expression for an element of the set, and we have a property that that has to be satisfied, right? So the expression here contains variables. In this case, the variable is x, and the properties reference the variables that are in the expression. So this is a really simple one. Right? Even numbers are not that complicated to define, but you could have more complicated ones, right? So, for example, the natural numbers are equal to x, where x satisfies two properties. X is an integer, and x is also greater than or equal to 0. Right? So that's another example of set builder notation. And in general, all of the properties, right, this is an and. The comma, right, is equivalent to a logical and. Oh, people are requesting that I write larger. I can definitely do that. Okay, the comma is a logical and, so you have to satisfy all of the properties. Let's see. Let's try writing this again bigger, right? So people can hopefully tell me if that's big enough. All right. So those are set builder notation. Set builder notation is pretty pretty useful. We're going to use it a bunch when we describe algorithms, for example. So algorithms may operate on sets that require set builder notation to describe. Set builder is also pretty useful in the sense that programming languages use it. So if you're familiar with Python, you might be familiar with their list comprehensions and set comprehensions. So a typical example of a Python list comprehension would be, of a Python set comprehension would be something like this. X squared for x in range of 4, right? So in Python, range of 4 is 0, 1, 2, 3, that set. And what this says, this expression refers to the set 0, 1, 4, and 9, right? So you can see that the Python set builder notation actually, the Python set comprehension actually corresponds really well to the set builder notation, right? It's a property, just like we had in the set builder notation, and then this here describes, there are some variables inside the expression. So sorry, we have an expression just like in set builder notation, and then we have properties that describe what the variables in the expression have to satisfy. And so now I think we're going to get to the first exercise that you guys are going to do, and let's see if I can figure out how to get that exercise to you guys to do. So what I'm going to do is I'm going to post on Piazza a link. And that link will lead to okay, so that link should lead to a site called REPL.it, and what that site gives you is a way to execute code in a web browser and check whether it matches the unit tests that I've written to see whether you guys are doing the exercise. So here is the description of the exercise. Let's see. So first we will get that, and then we will take this. All right, that looks like it needs to be bigger. All right, so here, whoops, maybe that's too big. Let's see if we can make it, there we go. All right, so here's the exercise. You should be able to write a function that when you're given an input set whose elements are strings, it uses set builder notation to find all of the elements of S that use only the letters A through M in either upper or lower case. And so given the input that you see here, cat, dig, dog, and eel, you should return dig and eel, right? Because cat has T in it, which is not a letter A through M, and so forth. And so what we're going to do is we're going to pause here for a little while, and we're going to give people a chance to complete the exercise. And I'm going to look at the submissions as you're doing it, and hopefully we should see everybody quickly being able to solve the problem. Oh yes, this is the TAs point out a good thing. Please log in with your Andrew ID to the REPL.it site, because that way we'll be able to match your submission with who you actually are. And it will, otherwise, we've had in past semesters where it was actually quite difficult to match students to their submissions for some sites. Oh yes, and there's only one exercise up there. Oh, okay. Apparently I gave you guys the wrong exercise first, but that's okay. You can do that exercise first. Here you go. Let's do this one first. This is, again, the same thing. They're both testing a similar thing. One is, which is to be able to use Python's set comprehensions in a way that practices set builder notation. So again, for both of these exercises, the important thing is to use set builder notation, right? To use Python's set comprehensions, because that's what I'm hoping you guys are going to be able to practice here. So here's the exercise that I actually made live. Sorry about doing it in the wrong order. You want to be able to find all of the elements of a set of integers that are not divisible by a list of small prime numbers, 2, 3, or 5. So given input 1, 2, 3, 4, 5, 6, 7, you should return 1 and 7 because 2 is divisible by 2, 5 is divisible by 5, 6 is divisible by 3, right? And the only ones that aren't are 1 and 7. Oh, there are people who are trying to log in with their Andrew ID and password. Don't do that. What you should do, it just requires an email. So use your Andrew email, right? And then create a password for the site. All right, we have our first submission in. That's great, and it looks like it's correct. So which is good, right? Because it passed all the unit tests. I'm glad that that means that it's correct. And so again, the correct solution should look a very lot like the set builder notation that you would use in math, but translated into Python code. We'll wait some more for other people to get a chance to do their submissions. All right, we're starting to get submissions that are using for loops. If you did it using for loops, please go back and do it using set comprehensions instead. So the goal is not to test your ability to write Python code or anything like that. The goal is specifically to test your understanding of set builder notation via the Python set comprehensions. I'm receiving a question whether students can edit their submitted code. I think what you need to do is just make another submission. So I'm going to, for people's reference, put up some examples of set builder notation just to keep that for just to make it easier for people. So, all right, so here I guess is an example, that's an example of a very simple Python set comprehension. In general, the syntax is you have curly braces to start and end, you have a expression, and then you have two types of clauses here. You have for x in an iterable, right? And you can do that multiple times for y in another iterable, right? And so forth. And these give you the range of the variables. And then you have the other one that we need is if, for example, x greater than or equal to 3, or if x plus y equals 5, right? Something like that, right? And you put that all inside curly braces, right? And so these clauses at the end, they correspond to the set builder notation, right? So, you know, for x and z here, obviously in Python you can't iterate over all the integers, but you can iterate over a range of them. And the ifs restrict the output, right? So they're like, we had the example x such that x is in the integers and x is greater than or equal to 0, right? The corresponding Python would be something like x for x in range of not all the integers, but let's say minus 100 to 100. If x greater than or equal to, well, I guess in Python you have to write something like greater than or equal to 0, right? And this should all be, I wrote it on 2 lines because I didn't have space, but it would be better to write it on 1 line in this case. So there are a few students who are asking about the level of programming that's required. So there will be programming assignments. You know, this is a course in the Carnegie Mellon School of Computer Science, so we do expect some programming. The goal is not to have the programming assignments be long, but to teach concepts that are potentially difficult, right? So here, this is a concept that probably a lot of people are not familiar with, the set builder notation. And so there's an assignment that's using a probably not so well-known feature of Python that happens to look exactly like set builder notation. So I don't expect that everybody knows Python set comprehensions ahead of time, but part of the goal for this lecture is to teach you, to give you practice with Python set comprehensions and set builder notation. So I guess the overall answer is you're not expected to know everything ahead of time, but you will probably learn some new things about Python throughout the course, and hopefully also some new things about math. Right, great. I'm starting to get more submissions. These submissions are all looking quite good, so that's great. One submission that I noticed used Python list comprehensions instead of set comprehensions. And that's fine because list comprehensions actually look exactly the same. But basically, if you used list comprehensions, that's basically exactly the same thing, except you wind up with square brackets instead, right? That gets you a list instead of a set. All right. There are people saying that they're having trouble making changes to code after submission. I'm not sure exactly. We'll have to figure out what's going on with that and get back. We'll have to get back to you guys later to see if we can figure out why people are having trouble with that. Some people are actually already done with the first exercise. If you're done, let's see, for right now you can probably just wait a little bit. I'm going to wait until most people are done with the first exercise, and then I'm going to go on lecturing about sets, or possibly post a second exercise. All right, so a lot of people seem to have gotten submissions by now. So what I'm going to do is post another example of an exercise that uses a slightly more complicated set builder or set comprehension notation. So let's do that one. Well, okay, so let's do this exercise next. So on the same classroom page, you guys should now be able to see another assignment called Only A to M, and that is open for submission as well. And that was the assignment that I tried to post before. So I will go ahead and go back to that assignment, right? And so this is similar, except it's using a more complicated property for filtering. And yes, of course, we're going to make solutions available after class. Oh, so some people are asking about the difference between a set and a list. That's actually a great question. So a list and a set are both a collection of items. The difference is that a list is ordered and allows duplicate items, whereas a set is unordered and does not allow duplicates. Right? So if you have the set 1, 2, 3 and you add 3 to that set, it's going to stay 1, 2, 3. Whereas if you have a list 1, 2, 3 and you add 3 to it, it'll be 1, 2, 3, 3. Right? And the list also has an order, so 3, 2, 1 is a different list from 1, 2, 3, but 3, 2, 1 is the same set as 1, 2, 3. I'm getting a question about whether submissions will be enabled after class. So no, the lecture, the problems will remain for you to look at and practice, but submissions will not count if you do them after class time. These are intended to be in class when you can get feedback from us. They're not supposed to be homework problems that you do after class. So we've had a few people who are having trouble seeing the second assignment. If you go back to the assignment page and just reload it, it should show up. That has fixed the problem for everybody who I've given that advice to so far. So I'm getting questions about whether it's okay to leave extraneous code in your submissions. The answer is it should be okay. So as long as the extraneous code doesn't, for example, throw an exception or some other problem like that. I've just tried it on the site and was able to get a submission to work with extraneous code. But if you're having trouble, the extraneous code might be the cause of the problem, and it would be a good idea to potentially delete it and try submitting again. So examples of extraneous code would be things that you put in to test your code, like print statements or assertions. So I'm looking at the submissions for the not div, and they're mostly really great. There are still a few people who used the for loops instead of actually using set comprehensions. All right, so we're starting to get a bunch of submissions on the only A to M exercise, and looking at them, they all look pretty good. There are a few submissions that use tests that are not quite correct for whether a string is entirely composed of characters A to M, but that's not a huge problem because that wasn't what we were trying to test, right? We're not trying to test your ability to use Python regular expressions. We're testing your ability to understand set comprehensions or set builder notation. So some examples would be that some of them test only for lowercase a to m instead of both lower or upper. Some assume that the string is entirely alphabetic. In other words, it tests that it doesn't contain NOP all the way up through Z, which will be, it'll give the wrong answer if there are like exclamation points or underscores. And there are some that use regular expression search rather than match, right? So a regular expression search will tell you whether there exists a part of the string that is using the characters A through M, whereas you can use a regular expression match to test whether the whole string has only characters A to M. I'm curious, by the way, how many people are still working on these assignments. So could you, let's see. So maybe if people would like, let's say 5 more minutes, could you send a text to one of the TAs, and the TAs can tell me now how deluged their text inboxes are. Whereas if you think that you've gotten to wherever you're going to go, you can text that as well. Sounds like a lot of people are still working, so we're going to give you guys some more time. And you don't need to keep texting the TAs. Oh, it sounds like a lot of people are maybe not as familiar with Python as they might like to be. We're gonna we picked Python for the exercises because it's a fairly commonly known language, but certainly we'll try and help anybody who isn't familiar with Python be able to catch up. So we'll try and provide some resources for students who need to learn Python. All right, so let's see. We are getting close to the end of time for the class, and a lot of students are still having trouble either with the exercise or with the mechanics. So what we're going to do, the exercises currently have a built-in timer so that you will start to fail a unit test if you submit after 3 p.m. today, the end of class. I guess actually class ends at 10 of 3, but we put the timer at 3 p.m. So what we're going to do instead, we're going to try to go back and help students who are having mechanical difficulties. And then we'll extend the timer so that students can go back. We'll try and figure out how students who didn't like their submission can resubmit, and we'll extend the timer so that people can go back and resubmit their exercises. So don't worry, and don't worry if you don't finish these by the end of class today. We'll figure out how to make sure to give everybody time to get both the mechanics and understand the exercise before the due date. And I think we're also going to just briefly try and finish the lecture notes on sets. So there's only a couple more things that I wanted to talk about on sets. I'm going to go back now to the whiteboard. Get a nice new blank page. So let's see, you're probably familiar with a lot of set operations like intersection and union and set difference. Maybe the least familiar of those is set difference. It's set difference is written x backslash y. That's the set of stuff in x that's not in y. And so you can actually write that in set builder notation, maybe some more practice, right? It's all of the elements x which are in x but not in y, right? So note the weird little backslash symbol, that's the notation for set difference. The next thing I wanted to mention is what are called tuples. So you probably will have dealt with those in programming languages before. So for example, the argument list to a function is a tuple. It's basically a fixed length list where each element of the list has a type, right? So if you know the standard main function in C has an argument list that's argc, argv, and argc has to be an int, and argv is an array of strings. And so the argument list to the main function in C is integer. It has type integer cross an array of strings, right? Which is written in C as, an int for integers and either car star star or car star argv array, right? So right, and then so the other use that you might see for tuples in programming languages is records, which are called, for example, structs in C, or most languages have them. Again, they're a data structure which has a fixed set of fields, a fixed list of fields. Each field has its own type, and every object has every field filled in. So a good example of a tuple would be you guys all registered for this class on SIO. The registrar has a database for this class that consists of students, what program they're in, what year they're in, and so forth. So you can think of that as a tuple, where the tuple is it's called a product type, where you have the first element of the tuple is the student, the second element of the tuple is an indicator of what program they're in, the third element of the tuple is an integer that tells you what year they're in, and so forth. So one of the ways that you can get tuples is what's called a set product notation. So if, set product operation. So if we have a set X, which is equal to 0, 1, and 2, and a set Y, which is equal to 3 and 7, the set X cross Y, right? So this is then the set product. This is equal to a set of tuples, and each tuple is going to be an element of X. Here 0, let's say 0, and an element of Y, let's say 3, right? So these are angle brackets, little pointy things. And then you're going to have one element of the set product for every way of picking one element of X and one element of Y. So we'll have 0, 7, right? The first element of X and the other element of Y. And then we'll have, 1, 3, and 1, 7, right? And the little angle brackets indicate tuples. By the way, if you're typesetting these in LaTeX, you should not use a greater than and less than sign. That will very much confuse anybody who's reading it. There's LaTeX symbols called L angle and R angle. For those of you who are LaTeX users. For those of you who aren't, you can ignore that, but I see a lot of papers coming by where people try and use less than and greater than, and it's always very hard to read. I'm getting questions about how the in-class exercises are graded. They're going to be graded exercises. So each in-class exercise could potentially be graded differently. But these exercises are going to be graded essentially on completion or not completion. So you'll get credit for each exercise based on whether you submitted the correct answer or whether you didn't. All right. So let's see. People are asking whether they'll be penalized for using for loops in the exercise. Yes, that's not the directions, right? The directions are to use set comprehensions. Now, don't worry, we're going to try and figure out how to reopen submissions so that you guys can go fix that. No, set comprehensions, you only have to use set comprehensions in the main function, the function we're grading, right? The function that actually builds the answer. You can use for loops in a helper function somewhere, as long as the final answer is being built in set comprehensions. All right, so we are basically out of time for the class, so we're going to stick around. I have office hours now, starting now for the next at least half an hour, depending on how many people come and ask me questions. For office hours, again, you can just text me on Hangouts, and I'll open up video with people in turn. And you can also keep asking questions on Piazza, and the TAs have posted their office hours to Piazza as well. So if you need more help, please go ahead and ask us questions. All right, and next time around, we're going to hopefully finish up with sets, and we're going to cover propositional logic as well. So the idea is going to be, for propositional logic, the goal is going to be for everybody to understand how to build proofs, how to build a cohesive argument, both in English and in propositional logic. All right, and so please also feel free to comment on Piazza. I know there have been some difficulties with the software that we've been trying to use. Please let us know about any difficulties. This is the first time that we've had live students interacting through this exact set of software, so I apologize for any difficulties that you have because of that. And we promise we will try and make sure to fix them, and we want to make sure that nobody gets penalized for having problems dealing with the software. So thanks, everybody. I'm going to stop the stream in another minute or two, and I hope you guys learned something from the lecture and from working on the exercises.